Hello, my name is Hakon, and welcome back to my channel and another little video in my ongoing series where I talk about my DIY synthesizer projects, which is where I use my limited but slightly slowly growing knowledge of electronics to expand the possibilities of my phenol modular synth. Um, Last time I talked a little bit about the status of my project, how I decided now to go with a Vero board front panel for my 4017 chip sequencer, and this is what I've been doing here. I showed you a mock-up last time. This is almost the finished product. It's still a work in progress, of course, because there is still lots of wiring left to do. Well, not lots, actually. There's not much wiring going on in here at all, because this is a very simple circuit. It looks slightly different from my mock-up. One of the differences is there is one less switch. I'll get back to that let's just talk about what I've got here so far. So I drilled all the holes, of course, which wasn't too hard. It's quite a forgiving material to drill in. These Vero boards, they're quite easy to drill. And then I have the outputs here, 5 individual outputs for the step sequencer. I've got the sequencer output here. I've got the socket for the chip here. I've got my Zoya input and output here, and also I got the sequencer input, trigger and power input here. So one thing I did change from last time. I was originally intending to have a direct connection from the Zoya input to the input that runs the sequencer and just switch it on and off. But I also said last time I do not want to buy any new components at the moment. So I'm just going to try to do this with what I have. And I only had 6 of these nice miniature toggle switches, which are really nice from Thonk. I bought them from Thonk, good web shop for buying stuff to do with modular synthesis and DIY projects. Also bought these potentiometers from Thonk as well. So this is the input and output section for the Zoya, and if I want to run the sequencer from the Zoya, all I have to do, of course, is to put a little patch cable from this socket here down to this socket here. So before I run through that, I'm going to show you also I've done with the push button. So these are the buttons I'm now using to indicate how many steps are running. So there's going to be one off button, which I would have hoped to be red. Actually, I may see if I can find a way to change the color to red. And then there's off and 1, 2, 3, 4, and 5 steps to indicate how many steps it runs through before it goes back to the beginning. And because the way I'm going to wire this is that on the 4017 chip, there is a there's a clock enable switch or enable pin, which I can connect to a switch now to make that stop the sequencer from running. And the other ones are where I route the reset pin to which of these different outputs. And I've attached this to a little piece of wood. I had to do this twice because the first piece of wood I used cracked. Most of the wood I have is old and dry. It's upcycled wood from different things, from furniture, from pallets, things like that. So what I'm doing, so this one goes, let's just see now if I can get this right. So it goes in here. It's a little bit of a tight squeeze now because I've been doing some wiring when this was out, so some wires are in the place or in the way rather. So it goes in like that, attaches with 2 wood screws, and it looks quite nice, and it adds a bit of strength to the whole thing as well. Looks nice from the back. I had to take it out now because I had to wire up these LEDs, and this was getting in the way for the soldering. So the LEDs here, at the moment, all of them are actually sharing one resistor up here. that may change because I think it looks quite nice to have individual resistors for each of them, so I might add that still. At the moment, though, they're all sharing one. And one thing I realized, by the way, after I put in the LEDs now and I wired up the resistor, and I realized that it would be nice to be able to switch off the LEDs. Now, one thing that I do, because I don't know enough about electronics yet to do it any other way, and that is these LEDs, they light up when the step is active, okay? But in order to do that, and the only way I really know how to do that is to use the voltage that's coming out from the 4017 chip to this step to also light the LED. That steals voltage. It steals a good few volts of power, and so it reduces the signal strength as well. Not quite by half, but maybe by 30 to 40% when I use the Zoya, that is. But in order for this sequencer to work on a lower power gate, like what I would get from the Phenol, these LEDs can't come on because they will steal all the power that's coming in. And there won't be any left for the sequencer. So I decided, after I'd actually put in all these components, after I'd done the LEDs, I realized I really need an on-off switch for those. So I'm going to put somewhere on this front panel now, there's going to be a miniature little slider switch, which I haven't found yet. I know I have one somewhere in my stuff. Maybe I'll put it down here or something. And for now, I've got this switch, which will be at the back, which switches the LEDs on or off. So I can switch them off if I want to run it in low power mode, as it were, and on for high power mode, which of course will look nicer. Another thing I did, I was originally intending for these toggle switches to go up and down, but there is a thing about toggle switches, is that whether on is up or on is down is a little bit ambiguous because people do it in different ways. I've noticed in the UK, for instance, where I live now, a light switch is off when it's up. In Norway, a light switch is usually on when it's up. People have different expectations when it comes to whether up or down is on or off. And so when I encounter switches that go up and down, I'm also never quite sure unless it is properly labeled. So instead, I find it more unambiguous to put them left to right. So left is off and right is on. To me, that always makes sense. And also, it's pointing in the direction of the output when it is on. And the same now with the whole sequence switch down here, which is now right, meaning it is on. So I'm using that to make it completely unambiguous to myself, so I won't get confused when I'm using this, that right is on and left is off. So yeah, these potentiometers, as you can see, they are just through-hole mounted now, and they're just soldered onto the Vero board. And of course, another nice thing about using the Vero board for this now is that they can all share the same ground strip. So all these are on the back here. It might be a little bit hard to see, but the strip that is the connectors that are to ground, which are the ones on this side, they all go down the full strip, and the other ones, I've removed some of the what do you call those things? Those the stripes of copper there. There's a name for it, and I've just forgotten it at the moment. Anyway, there's a very particular name for it in electronics. What do you call those things that connect one thing to another? Anyway, never mind. So that's quite easy to do, and also because of they have these little things on the side, which means that when I just pop them in, they just stayed in place until I could solder them, which was brilliant. And then I have the diodes here, which are for the routing the signal from each of the individual output channels now, routing it down to the common sequencer output. So, and of course, the point of the diodes is that the voltage only goes in one direction. And also, as I found out when I was prototyping this, if I touch the diode legs, interesting things start to happen. So I made sure that they were properly exposed on the front panel now, so I can touch them easily if I need to and see if I can get that effect again. I've got some black wires here visible on the front. These are ground connections. I just thought I'd do that. They don't have to be on the front, but I thought it looks quite nice. Let's just go through the signal flow a little bit here now. So the Zoya input here goes to these ones. It has a ground connection, which is connected to ground, and also it has an input and an output. And I've made I think the input is now the red one, and the output is the black one. So when the signal comes in from the Zoya, the signal goes into this output with an attenuator. And if I want to send something back to the Zoya, it goes in here with an attenuator as well. And if I want to run the sequencer from the Zoya now, I take this output here and I patch it into this, which is the sequencer running input, which also has a trimmer pot, which probably it doesn't need. But it means I can adjust the voltage coming in on the fly from one spot here. What this will do is actually change the output levels of all the different steps at the same time. So that can be quite useful, of course, in my way of doing music. Now, there's one more jack here that I haven't talked about or mentioned yet. This one is intended to be the power input for additional LEDs. Now, I did say that I was going to use the power to the sequencer to run these LEDs because they flash up. I still don't know how to use transistors. So because if I knew how to use transistors, I might be able to run these LEDs on the same circuit. But what I wanted to have LEDs for as well is I want an active LED here indicating that this sequence is, or the whole sequence is on. And also I wanted some indication of how many steps are on and also whether the sequencer is off. So I wanted to get power from the phenol for that. So at least that will be one option, either from the phenol or on the back of the panel. I will also put a power socket that I can plug a power adapter into probably and run those from there as well. Because I have loads of power adapters, actually. I can use any of those. The nice thing about connecting it with a banana jack, though, is that I can also vary the input a little bit in different ways and therefore get variation in strength of these other LEDs, which can look quite nice. That was the plan. So I will have some LEDs for the buttons. I haven't decided where to put those. I was thinking maybe have a little row down here, but then I realized I could also squeeze them in between here as well, and that might look better. So I'll see what I'm going to do about that. I have not decided 100% yet. So what happens? Signal flow. Yes, I keep distracting myself. So the signal comes in here, which goes to the clock input of the 4017. And the button row here decides where the reset pin, which is also down here somewhere, which step that connects to. So when you connect it to a certain step, for instance, if you take the reset pin and connect it to step number 3, it will only play steps 1 and 2, and so on. So it's very important to not mess this up, of course. So when I get to the wiring up the buttons, I must remember that the reset is always one step ahead. So the reset pin for playing the whole 5-step sequencer is actually not output 5, as you would think, but it is output 6, which of course doesn't have its own output channel, but of course it still has a pin on the chip. And then we have we're only using 5 of the 10 outputs from the chip, and they are routed to these places here. I have wired them up, haven't I? Yes, I have wired them up already, as you can see here. And of course they go via the switches. So the first port of call for the output from the chip is to the switch, which tells you whether it's on or off. If it's off, I think nothing happens at all. I don't even get yes. I do. Yes, I see that. You do get the LEDs lighting up even though the step is off, because I just want to indicate where the sequence is. But the power is not routed to the output. It is routed to the LED always, but not to the output. And I do like that. It is also connected to the output via the potentiometer. So the idea is that I can send in from the Zoya, for instance, I will get 5 volts. So I will get pulses of 5 volts coming in, which will both trigger and gate the sequencer. And it will also, and of course, minus a few volts for the LED, and it will have about 3 volts left. And those 3 volts will be sent out here. If I start attenuating this, then of course the output will be reduced from 3 volts. Now it's down to 1.5 volts when it's halfway up, and down to 0 volts when it's all the way to the right. So if I remember correctly, if I wired it correctly, I may have wired it the opposite way, I'm not sure now. And then from the potentiometer, it goes to 2 places. It goes to this output, and it goes to the diode. And then the diode goes, all the diodes here go into this output here, or rather, they go through to the switch here. And then when the switch is on, it goes to the output there. So, and I still haven't tried whether I can use the individual outputs and this at the same time and what happens. It should work, actually. It should work, theoretically. So I'll be interested to see how that affects the sound. Right, I think that is mostly it, actually. I can't really think of anything else that I wanted to say about this now, but this is how it's coming along. I'm thinking it's looking quite nice. It's definitely looking better than my previous version of soldering a DIY project. It does help to have it on a Vero board now, because I'm using these strips. So every time there is, for instance, this row of LEDs now, of course, all of the ground connection legs are on the same strip, which means they all connected together and then to this resistor here. And the same with all these potentiometers, all the ground legs are connected on the same strip, and the same here as well. So these things do help to make things a little bit tidier, because there are fewer wires needed. And I've also tried to mix the colors quite a lot here as well. I mean, there's no color coding or anything. All I've got so far is, of course, that black means ground. But otherwise, the color here, just to get a good variety of colors, so it's easy to see what connects where if I need to do some troubleshooting and fault finding at some point. So there we go. It is coming along. Not much left to do, actually. I can see all these outputs are wired up. These ones are wired up. The switches there are wired up. These LEDs are wired up. It looks like yes, the sequencer output is wired up. I'm not started on the LED circuit, of course, because that's the last thing I'm doing. I've wired up this bit as well. It looks like it really is. The only things left to do is to wire up the LED circuit and also put in the LEDs. That will be small LEDs, I think, for the 3mm LEDs. These are 5. 3mm LEDs for the step indicators. And then I think, yes, then of course it is the switches. Now, the switches is, of course, these have 4 different poles, actually. And of course, one of the poles will be for the reset point of the chip to steps 1, 2, 3, 4, 5, or 6. Or not for 1 really, for 2, 3, 4, 5, and 6 to get the number of steps, and then an off state. And then also I'm using one of the poles to control the LEDs that light up, and also to without going via the switch, one LED will also be lit up with the just directly from the input as well, which is via this switch. Now, another thing, these switches, all these miniature switches now, they are all double pole, which is very useful. One thing I found is that there's no point getting single pole, single throw switches. It's much more convenient to get double pole, double throw. So all these are on, and they have 2 poles. You can still use them as a regular on-off switch, but you can also use them as an on-on switch, and you can use them for 2 different things. So they cost the same, they take up the same amount of space, and you can just do so much more with them. So there's absolutely no point, unless it's for sort of ultimate reliability or something like that, to get single pole, single throw switches. These are just so universal. So that means I could also have, for each of these steps, I could also have had an extra LED indicating whether the step was on or off. I did try to do that in a mock-up, and I thought it looked a bit messy to have one more LED as well because of these ones being there already. So I think I'm giving that a miss, but I do have the option of adding it in the future as well, and I could actually squeeze it in between here, just a tiny miniature LED, but I'm not too sure about that. So that is my plan. So a little bit of wiring left to do, and it should be good to go. And hopefully, but I haven't tested it yet, so there might yet be some problems. You never know with these things. And also, if I haven't removed the copper properly in places where it needs to be removed, then of course there will be short circuits, and I'll have to see if I can find those. I think I've located all the places I need to remove the copper, the traces, that's the word, isn't it? In order to make this work. Actually, I see I have not done it on the LEDs here yet. So these ones, the positive input of the LEDs still need to have some of the traces removed so they don't all connect together. I haven't done that yet. It's easy to forget. So that is the status of my project at the moment, and so I hope you enjoyed watching that, and I hope you found it useful and or inspirational to see what I'm doing with my synth DIY projects. Maybe you have a synth DIY project as well. It doesn't have to be too complicated, not to start with. And of course, if you have more electronic skills, or if you develop your electronic skills through doing things like this, starting with something simple, then of course you will get better and you will be able to do more things. Indeed, I started just doing attenuators, and for me that was, I mean, it is one of the most basic things you can do, is to just make an attenuator, input, output, attenuator, nothing fancy, nothing else. It's a nice place to start, but then this is sort of a few steps onwards. And also originally I wasn't planning to use any chips because, well, yeah. But now I'm confident doing it, and I'm comfortable doing it, and I think it's nice to feel that your skills at electronics or anything else are advancing, that you can do more things. So yeah, and also I think it looks quite nice. Anyway, thank you very much for watching, and if you enjoyed it, please like, share, comment, subscribe, all those things, and I'll see you in my next one. Goodbye for now. Bye-bye.